All right, the first thing we're going to talk about here is intersection. The intersection of two sets, A and B, looks like this. So this symbol right here means intersection. A intersect B means you want all of the numbers or elements, x, that are in both sets A and B at the same time. So x is in both A and B. The key here is and. You want to really think of the and as meaning intersection. Intersection and are the same thing, really. For example, let's say we have our set A consisting of the numbers 1, 2, 3, and 4. And we have set B, which consists of the numbers 2, 4, and 6. The intersection of those two sets would be everything that they have in common that are in both A and B. So I guess I could put up here what they have in common, common elements. What do they have in common? Both set A and B have a 2, and they both have a 4. And so the intersection of these two sets would be 2 and 4, like that. It's the intersection of the two sets. Here's another example. Let's say set A is the set 1, 3, 4, and 5. And set B is 1, 2, 3, and 4. And we'll even throw in a set C here. Let's say set C is 5 and 7. What then would be A intersect B? What do A and B have in common? Let me see here. They both have a 1. They both have a 4. And they both have a 3 as well. All right, so the intersection of sets A and B would be 1, 3, and 4. Let me fix that. There we go. 1, 3, and 4. What if I ask for the intersection of sets A and C? What do sets A and C have in common? They both have a 5, and that's basically it. And so this intersection would be just the number 5. And what do sets B and C have in common? What if I wanted B intersects C? Well, notice that set B and set C, they don't have anything in common at all. And so we would leave our set empty, or we have a symbol for that, as we recall from a previous lesson, empty set. Empty set. Okay. So that's intersection. Now, how does this work with inequalities? Here's an example. Say we have x greater than 3 and x is less than 5. Notice that it's we have two inequalities here, and it's an and statement. Now, as I said earlier, when you see an and, that really means the same thing as intersection. So I know that means this. Now, since it is an intersection, what I want is all x's that are greater than 3 and at the same time and less than 5. I'm going to draw a number line. Simple little number line here. And what I'm going to do is some scratch work first here. I always found that this helps out. It helps avoiding errors here. First of all, x greater than 3. What are all the numbers that are greater than 3? They're from here onward this way. Yeah, I did an open circle, actually, the parenthesis here, isn't it? Okay, the way our book works. All the numbers that are less than 5, x less than 5, that would be from here this way, like that. Now, that's just my scratch work. Now I'm going to put my answer actually on the number line. I'll use blue for that. I want the intersection of the two sets. It's what they have in common. Well, that means the overlap. What do they have in common? This part right in there, the overlap. From 3 to 5, like this. That's my answer. And in our interval notation, that would be written parenthesis 3 to 5 parenthesis. Okay, so this is the graphical representation, and this is our interval notation for the answer. Okay, so the key here is when you have an and statement, that means intersection, and what you're doing is basically you're looking for the overlap of the two lines. Here's another one. X is less than 3, and x is greater than negative 1. Now let's put some equal signs here. Okay, I've drawn a number line. Let's see, negative 1, 0, 1, 2, 3. Will look something like that. Just a crude number line. Now I'm going to do my scratch work. I'm going to graph everything that's less than or equal to 3, which would be bracket going this way. Now I'm going to graph everything that is greater than or equal to negative 1, which is from here on that way. This is an and statement, so I want the overlap of the two lines, or what they have in common. Well, that would be right here from negative 1 to 3, just like that. That's my answer. In our interval notation, that would be bracket, negative 1 to 3, bracket. And really what this means is if you take any number here between negative 1 and 3, for instance 2, what does 2 do? It works for both inequalities. 2 is less than or equal to 3, and it is also greater than or equal to negative 1. Any number in this interval is a solution. Here's another. X less than or equal to 2, and x is less than 4. My number line again. Let me fix that. Okay, scratch work. Let me use red for that. All the numbers that are less than or equal to 2 are right there. All the numbers that are less than 4 are right there. Now, once again, this is an and statement, and so I want what they have in common. In other words, just the overlap is my answer. Notice that in this case, the overlap is from here, blue. The overlap is from here on out. That's my answer. In our interval notation, that would be negative infinity up to 2 bracket. There's my answer. One more of these. X is less than 1, and x is greater than 3. Scratch work. X less than 1, that would be these numbers out this way. Greater than 3 are these numbers. Remember, this is my scratch work. It's not my answer. Now I'm going to write the answer on the number line. This is an and statement, and so you want what they have in common. But notice they have nothing in common. There's no overlap. And so I'm going to leave the number line completely blank. There is no answer to this. And after all, what number is less than 1 and at the same time greater than 3? It's not possible. So this has no answer. This is that empty set again. Empty set. All right. What do we do if we have something like this? X plus 1 is less than or equal to 9, and x minus 2 is greater than or equal to 3. Well, before I can start graphing and get the solutions, I have to solve each one for x first. So really, it's just one extra step here that's involved. Subtract 1 from both sides here. This is really x less than or equal to 8. Add 2 over here. This is really x greater than or equal to 5. Okay. I've got each one solved for x, and so now I'm going to do exactly the same thing I've been doing. 5, 6, 7, 8. Scratch work. All the numbers that are less than or equal to 8 are right there. All the numbers that are greater than or equal to 5 are here. This is an AND statement, and so the solution is the overlap, or what they have in common, which would be from 5 to 8, just like that. Our solution in our interval notation is bracket 5 to 8 bracket. All right, let's do one more like this. Negative 3x minus 2 is greater than 5, and 5x minus 1 is less than or equal to negative 21. Okay. Once again, before I can get my solution, I have to solve each inequality for x correctly. I'm going to add 2 to both sides here. Negative 3x is greater than 7. Dividing both sides by negative 3. Have to remember to switch the sign, if you recall. I just divided by both sides by a negative number, so this is x less than negative 7/3. Now over on this side, add 1. 5x is less than or equal to negative 20. Divide both sides by a positive 5. Don't switch the side there. X is less than or equal to negative 4. Okay, I've got each one solved for x. Now I'm going to do my scratch work here. Negative 7/3, I'll just pretend that's somewhere in this area. And negative 4, oh actually, let me fix that. Try that again. Negative 7/3, that's actually negative 2 and 1/3. So that would be, let's see, negative 4, negative 3, negative 2, negative 1. Negative 7/3 would be right around this vicinity, this location right about there. Okay, scratch work. X less than negative 7/3 would be those numbers. X less than or equal to negative 4 would be these numbers. The bracket is an AND, so I just want the overlapped region, and notice that it's over here. Those are my solutions in our interval notation. That would be negative infinity to negative 4 bracket. There it is solved. Okay, so those are examples on how to handle intersections or AND statements and compound inequalities. The other type is the union. The capital U symbol here represents union. Set A union set B means all x's, or all numbers, such that x is in set A or it's in set B. The key word here is or. When you see an or, that means union. Or means union. For example, now let me fix that. Let's say we have set A consists of the numbers 1, 2, 3, and 4. And set B consists of the numbers 2, 5, and 7. And we want A union B. What I do is I just write down every number that's either in set A or in set B, or possibly both. I have a 1 in here, so a 1 will go there. This one has a 2, that one also has a 2. You don't write it twice, though. 2 is in one of them. So we write it down. I see a 3 up here, so a 3 goes in there. There's also a 4. This one has a 5, so that goes in there, and this one is a 7 as well, and that goes in there. So I think I've got everything. And that's A union B. Okay, so what I've done is I've wrote down every number that's in set A, or it's in set B, or possibly both. Now with an inequality, we would have something like this. Let's say we got x is less than 3, or x is greater than 5. Now, as I just mentioned, when you have an or, that really means union. Now, just like with the and statements, what I'm going to do is some scratch work first. Three, 4, 5. Okay. X less than 3. All the numbers that are less than 3 are right there. X greater than 5 are these numbers right here. Okay, now, this is an or statement. So what I want is not the overlap. That would be an and. Don't get them mixed up. An or means you want to keep everything that's in one set or the other. Now, what that really means here is, graphically, what you're going to end up doing is basically keeping everything that was shaded at least once. I'm going to jot that down. That's sort of a short way of thinking about it. Just keep everything that is shaded at least once. Well, these numbers out here have been shaded, and these numbers have been shaded, and so that's my answer. Many times with these ors, the scratch work will look just like the solution. Not all the time, though, as we'll see. But this is our answer here. I've just kept everything that was shaded. Now, how do we write this in our interval notation? And see, it's got two pieces to it. This part over here is negative infinity to 3 parenthesis. This part on this side is parenthesis 5 to positive infinity. And we, since it is an or statement, we combine them with a union symbol. That would be the solution in our interval notation. Here's another one. Say we have x is less than or equal to 3, or x is less than or equal to 5. Scratch work first. All numbers that are less than or equal to 3 would look like this. Less than or equal to 5 would be these numbers. That's my scratch work. Now, this is an or statement. It is not an and, so I don't just write down the overlap part. This is an or, and that means that I just basically keep everything that has been shaded at least once. Well, notice that everything has been shaded from here all the way over. And so that is my solution. In our interval notation, that would be written as negative infinity to 5 bracket. So notice in this example, my solution didn't look exactly like the scratch work above it. Here's another one. X greater than 3 or x less than 5. Scratch work first. Greater than 3 are these numbers. Less than 5 are these numbers. It is an or statement, so we want everything that has been shaded at least once. That would be our solution. Notice that everything has been shaded. And so I'm going to shade the entire number line here, like that. Everything's been shaded. And the way we represent that, that means everything's a solution. And in our interval notation, that'd be written as negative infinity to positive infinity. And let's do one more example here. (6x minus 4) less than 2x, or negative 3x is less than or equal to negative 9. First thing we got to do here is solve each one for x. So let's do that. I'm going to subtract 2x from both sides here. And at the same time, I'll add 4 to both sides. So that's 4x less than 4. Divide both sides by 4. We get x less than 1. Over here, I have to divide both sides by negative 3. If I do that, I have to reverse the sign, of course. It says x greater than or equal to a positive 3. There it is. Okay. I've solved each one for x. Now I'm going to draw my number line and do my scratch work. Less than 1 are these numbers. Greater than or equal to 3 are these numbers. This is an OR statement, and so I just want to keep everything that has been shaded, and that would be these numbers and these numbers here. This is one of those cases where the scratch work looked just like the answer. Interval notation, that would be negative infinity to 1, parenthesis, union, bracket 3 to infinity. And there's our lesson on compound inequalities.